So we're going to jump to 8.6 and work with system of nonlinear equations. So again, if we look at these two equations, we have x times y equals 3 is one equation. Notice that that's not linear because if we solve for y, you'd have y equals, you'd actually have y equals 3 over x. And if you solve this one for y, you'd have actually y squared equals 12 minus 3x squared. And if you take the square root of both sides, you actually get this plus or minus situation. Y equals plus or minus the square root of 12 minus 3x squared. So notice that the second one's not even a function. It doesn't pass the vertical line test either. Because remember, if you put something in, you're going to get two solutions out. So this doesn't represent a function. We can graph them. So if we look at the graphs, we have y equals 3 divided by x. But when I graph the second function, I actually have to graph two functions to make it work. Because as it is, it's not a function, but if I break it apart, I can graph these two individuals, which will make the whole. So the square root of 12 minus 3x squared, and then the opposite of the square root of 12 minus 3x squared. Just by looking at them, the first equation is a rational expression, so it's going to have those asymptotes and things like that. So it's going to be what's called the reciprocal function that's got a vertical stretch of 3. The second equation, x squared plus y squared, that actually represents, this is going to be elliptical. It's going to be almost circular, but it's not going to be a circle. It's going to look more elliptical. So if I just come back over here and turn this one back off, and then turn that one off to start with. If we graph, that's what the first graph looks like. So it's kind of this rational function. Notice that the y-axis is the vertical asymptote. So if we go to y equals, if I turn this one on and graph it as well, notice that it creates like half of a circle. And then if I y equals again and come over here and turn this one on and graph it, notice that creates the other half of the circle. So it looks like there's 4 different spots that this intersects, okay? So let's see if we can find these algebraically. The easiest way to do it algebraically is, notice how if I solve this first equation for y, I can use substitution into the second equation. So I can actually substitute 3 over x in for y in the second equation. So what we end up with then is this 3x squared, and I can replace the y with 3 over x and square that, and that's going to equal then this 12. So if I simplify this, we have 3x squared plus, if I square this, this is going to be 9 over x squared, and that's going to equal 12. Now, to get rid of fractions, we would have to multiply by x squared. So if I multiply this by x squared, I got to multiply everything by x squared. So what happens is this becomes 3x to the 4th plus 9, because the x squareds are actually going to divide out, and that's going to equal 12x squared. So what I can do is set this to 0 now, like a quadratic. So this is going to be 3x to the 4th minus 12x squared plus 9 is equal to 0. So let's try to treat this like a quadratic. So since I have a leading coefficient, what I want to do is multiply the 3 times the 9. That's going to be a 27. Are there factors of 27 that add up to a negative 12? So we have 1 and 27, and we have 2 won't work. 3 times 9 does. I believe 3 times 9 is That is 27. So yeah. And notice that if I make those both negative, a -3 times a -9 is still a positive 27, but a -3 and a -9 is a -12. So what I can do then using quadratic notation is, what squared gives me x to the fourth would be x squared. So this actually turns into, it's easier to do this in a 4 square pattern. Let me do it that way. So it's easier to draw this up in a box, because this looks like this is factorable. So remember, to factor this, we're going to have the quadratic term is going to be here, 3x to the fourth. The constant's going to be over here, the 9. And then the -3, it's going to be a -3x squared. It's going to be the middle term. And the -9x squared is going to be the middle term. So if I factor out the GCF, you're going to see that they both have a 3 and an x squared in common. So 3x squared can come out. So what times 3x squared gives me 3x to the fourth? I need another x squared there. And what times 3x squared gives me -3x squared? I need a -1 there. And what times x squared gives me -9x squared would be a -9. And does -9 times -1 give me a 9? Yeah, so it is factorable. So this 3x squared minus 9 times x squared minus 1 is going to equal 0. So since it's factorable, we can use the multiplication property of 0 and just set each factor equal to 0. So 3x squared minus 9 must equal 0, and x squared minus 1 must equal 0. So if I add 9 to both sides, we get 3x squared is equal to 9. Divide both sides by 3, x squared equals 3. If I take the square root, that's going to be a plus or minus, then square root of 3. Since we cannot take the square root of 3, we leave it as that. Over here, we would have x squared is equal to 1. In other words, x could equal a positive or a -1. So notice that we have 4 different values for x, which means we have to have 4 different values for y. So remember, y was equal to 3 divided by x. So notice how when we solve this equation for y, we have 3 over x. So I actually can use that equation to find what y is. So I have y equals 3 divided by the square root of 3. Let's see what the directions say if there is anything special about this. They want exact answers, and they want to simplify. So remember, you cannot have a radical in the bottom. So you got to multiply the top and bottom by a radical 3 to rationalize it. So this becomes then 3 radical 3 over 3, which means that becomes the square root of 3. So if I put a -1 in, y equals 3 over negative square root of 3, that's just going to be the same thing except a negative square root of 3. So then I have putting a 1 in. So if I put y equals 3 over 1, that's going to be 3. And if I put 3 over -1, that's going to be a -3. So if I could put this all together, so you have 4 different x's. So they want us to write order pairs. So when x was 1, we got 3. When x was -1, we got -3. So that was these over here. When x is 1, we got 3. When x is -1, we got -3. And then when x was the square root of 3, y was the square root of 3. So we have the square root of 3, comma, square root of 3. And then when x was a negative square root of 3, y was the square root of 3. So we'd have those 4 order pairs. So the question is, what is the square root of 3? So that's like 1.732. So if I go back to my graph, if we could go to second calculator, I wonder if we can find some zeros or some intersection points. Number 5. So first curve, Okay, we're going to be on this one. So if I hit enter, go to the second curve, which is going to be the black one. Oops, gotta go to the third curve actually. So let me turn that other one off here. Y equals. So do second calculate again. Whoa, daddy, let's quit there. Second calculate for the intersection. So if I do these down here, second calculate. So the first curve, get close to that intersection point. Second curve, hit enter again. Let's see. Let's see there. There we go. Hit enter. Yes. Notice that that takes me to -1, -3. Did I get a -1, -3? I did. Okay, so let's see if we can do that again. Second, calculate 5. First curve, enter. Second curve, enter. Enter again. And notice that gives me -1.73, -1.73. I believe that's what we said the square root of 3 was. So I think that was this one here. I just forgot to put the negative there. So we got that going on there. So you can kind of see that. So to do the other part though, I have to go y equals, I have to turn this one on and this one off, since I have 3 different graphs there. So hit second calculate again and do 5. Notice it's going to do these 2 intersection points. So the second calculate, number 5 again. So first curve, hit enter. Second curve, hit enter. Guess. Notice it takes me to that 0.13, which we do have. And then if I do that again, second calculate, intersection, first curve, hit enter. You just want to be close to that intersection point. Looks good. And we do get 1.73, 1.73, which was the square root of 3, the square root of 3. So that checks out. So we can do it. We can verify the thing graphically, but the catch is this is not a function, but if I put the 2 functions together, notice how it creates the whole equation, but notice how this actually is a circle, and a circle actually, to graph it, has to be broken into 2 separate functions to pass the vertical line test. So that's what we would be looking at. Notice how those are not linear.